Welcome back, friends. In the previous video we were looking about the effect of different factors on equilibrium, and let's conclude with this video. And in this video we'll discuss about the effect of temperature, catalyst, and effect of noble gases on equilibrium. So don't forget to subscribe the channel and share the link to your fellows. Biology, physics, and advanced math periods will continue in this channel. So we are looking on how temperature changes the position of chemical equilibrium. A change in concentration, pressure, or volume alter the position of chemical equilibrium, but not the magnitude or value of equilibrium constant. However, the change in temperature changes the value of equilibrium constant. To understand the effect of temperature, we must know whether the reaction is endothermic, that it absorbs heat, or exothermic. So reaction ambazo zinatoa heat tuki increase temperature zinaenda backward. Hizi reaction ambazo zina absorb heat tuki increase temperature manake tuta increase heat, kwa tuta favor forward reaction. Now that's according to Van 't Hoff law of mobile equilibrium. The increase in temperature favor endothermic reaction, while the decrease in temperature favor exothermic reaction. This is called Van 't Hoff law of mobile equilibrium. So we can state the Van 't Hoff law of mobile equilibrium. It states that for reversible reaction at equilibrium, the increase in temperature favor forward reaction for endothermic reaction and backward reaction for exothermic reaction, while the decrease in temperature favor backward reaction for endothermic reaction and forward reaction for exothermic reaction. So as you can see, increase in temperature favor forward reaction for endothermic and backward for exothermic, while decrease in temperature favor backward reaction for endothermic. Backward to decrease inako backward. Now forward reaction for exothermic. So that's all about temperature. Kama unataka tujue reaction is endothermic or exothermic. And about the effect of catalyst, the function of a catalyst is to speed up the reaction by lowering the activation energy. So catalyst does not alter the position of chemical equilibrium, but catalyst make the equilibrium to be reached earlier. The catalyst lower the activation energy of the forward reaction and the reverse reaction to the same extent. Due to this, there is no shift in equilibrium or change in value of equilibrium constant. Therefore, we conclude that the catalyst has no effect on equilibrium system. So as you can see, catalyst has no effect on equilibrium system. We have some of the worked example here to write the expression for the equilibrium constant for the given reactions here. But we already discussed these kind of reactions, these kind of questions earlier, that if we have all gases, we need to include all of the reactant and product in our reaction. But sometimes if we have solids and gases, we can't include all. So you just look here for the states of reactant and the products, and then you just write your KC expression. But now let's finish the topic with the discussion about the effect of inert gas on equilibrium. This is also asked in the exams, effect of inert gas on equilibrium. Now the effect produced due to addition of inert gas which do not react with any gaseous molecule, product and reactant on the equilibrium of reaction can be predicted quantitatively as follows. So you can predict the effect of inert gas. First, inert gas added keeping the pressure of the system constant. So you must know we added the inert gas keeping the pressure of the system constant or volume of the system constant. Addition of inert gas increases the volume of the system, which in turn causes the equilibrium position of the system to move in the direction of the large number of gaseous molecule. Kama tunavyojua kwamba tulisoma kule kwenye change in pressure and volume, kwamba tuki increase pressure manake volume inakuwa inapungua. Kwa hiyo volume ikipungua, equilibrium ina move toka kwenye volume kubwa kwenda kwenye volume ndogo. Tukidecrease pressure, volume inaongezeka, equilibrium ina move toka kwenye volume ndogo kwenda kwenye volume kubwa. Lakini tukiadd inert gas keeping the pressure constant, addition ya inert gas ita increase volume. Increase volume ita move toka kwenye volume ndogo kwenda kwenye volume kubwa, position of chemical equilibrium. Kwa hiyo position of chemical equilibrium itakuwa hivi, kama change ni n, yani number of moles of product minus number of moles of reactant ni positive, ita move kwenda right hand side, kwa sababu kule ndo kutoka kuna namba nyingi. Kama change in n is negative, ita move kwenda left hand side, na kama change in n is 0, ita remain unaffected. Lakini remember, hiyo ni addition of inert gas keeping the pressure of the system constant. Lakini inert gas added keeping the volume of the system constant. Addition of inert gas into a system at equilibrium and a constant volume causes an increase in pressure of the system and an increase in the total number of moles in the system. Therefore, under constant volume, tukiweka constant volume, tuna increase pressure and number of moles. Uelewe hapo. Under constant volume at any temperature, the ratio of total number of moles and total pressure remain constant. Kwa hiyo total number of moles kwenye system na total pressures remain constant. Zikiremain constant is that no change in any variable. Na kiufupi hapo, addition of inert gas at keeping the volume of the system constant does not alter the position of chemical equilibrium. As the result, no change in any of the variable, and the amount of the variables and amount of substances at equilibrium remain unaffected by addition of inert gas. The equilibrium position of the reaction remain unaffected. So, sample question, for example, if you asked, sulfuric acid is manufactured by the contact process, which make use of equilibrium reaction, EOP, sulfur dioxide, oxygen, sulfur trioxide. Heat is given out in the formation of sulfur trioxide. If it is given out, means it is exothermic reaction. State what effect would be on the equilibrium concentration of sulfur trioxide if equilibrium concentration of nini? Sulfur trioxide if first pressure were increased. Manake pressure were increased ni pressure of the system. Na kama unavyoweza kuona hapa, volume ya huku na huku zinafanana. Kwa hiyo if the pressure is increased, concentration of sulfur trioxide. Kama pressure ya system nzima imekuwa increased, concentration of sulfur trioxide haitabadilika, itakuwa ni unaffected. Kwa sababu gani? Pressure does not affect reactions which have the same volume of reactant today. Concentration of sulfur trioxide will be increased, therefore reaction proceed with the reduction of sulfur, thus increasing pressure will shift the position of. Remember, for this answer that the boy who was writing the notes, writing the answer, kwa sababu hizo notes hazikuwa za kwangu. Kwa hiyo ni kwamba kama volume zinafanana, pressure haitabadili chochote. Ila tukiongeza pressure moja, let's say sulfur dioxide, if we increase pressure of sulfur dioxide, equilibrium will shift forward. Or if we increase pressure of oxygen, equilibrium will shift forward. But if we increase pressure of only one, if we increase pressure of the whole system, the equilibrium will not change. So the concentration of sulfur dioxide will not be affected. Second, the temperature were raised. Because the reaction is exothermic, gives out heat energy. Raising temperature will favor the backward reaction. And if the backward reaction is favored, it means the concentration of sulfur dioxide will be reduced. So concentration of sulfur dioxide will be increased. This is not true. Will be reduced since heat is given out. The forward reaction is exothermic. So increase in temperature, shift position of equilibrium to the left. And if it is to the left, simply here the concentration of sulfur trioxide will be reduced because some equilibrium to shift kwenda left, and hence the production of sulfur trioxide will be decreased. Pia tunaweza kuona baadhi ya example hapa ambazo ni maswali ya hizi factors, baadhi ya examples. Example 2 hapo. Example 2, The equation for the reaction by which ammonia is manufactured inakuwa hiyo hapo. Alafu swali muulizo, what would be the effect on the equilibrium concentration of ammonia? 1. Increasing temperature. 2. Increasing nitrogen concentration. Kwa hapa nadhani tu swali was incomplete, lakini kitu ambacho utakiwa uambiwe hapa pia ni kwamba reaction ni exothermic au endothermic. Now for this reaction, always change in heat is negative, meaning that the reaction is exothermic. So increasing the temperature will shift the position of chemical equilibrium backward. Sorry, B wanauliza equilibrium concentration of ammonia increases if the temperature is lowered. Increases if the temperature is lowered. Is heat evolved or absorbed? So kumbe hii data iko na umuhimu kwa sababu umekuja kusema hapo kwenye B kwamba ammonia concentration inaongezeka temperature inapokuwa lowered. Kwa hapo maana yake lazima ujue reaction yako ni exothermic. Why is catalyst used in the reaction? So catalyst is used so as to increase the rate of reaction between nitrogen and hydrogen to produce ammonia. Catalyst does not alter the rate of chemical reaction, does not alter the position of chemical equilibrium. I mean, catalyst does not alter the position of chemical equilibrium, but it increases the rate of chemical reaction. So catalyst is added so as to attain the equilibrium earlier. So for the first question, if temperature is increased, the concentration of ammonia will be decreased. I'm very sorry because you will see some of the mistakes in these notes because I was not the one who wrote these notes. So nitakuwa narekebisha hapa nafundisha. Concentration of ammonia will be decreased because the reaction is exothermic. Now increase in nitrogen concentration, the concentration of ammonia will be increased because of gani to increase in nitrogen to increase concentration of reactant. So the position of chemical equilibrium will shift forward. Heat is evolved, low temperature favor forward reaction. If exothermic reaction according to the Van 't Hoff, this is exothermic reaction. And for the question C, high percentage yield of ammonia is involved by employing low temperature. But at low temperature, the rate of production for the gas is very slow, and hence a catalyst must be employed to increase the rate of production of ammonia gas by enabling the equilibrium to be reached earlier. Na swali la tatu hapo kwenye factors, at 400 degrees centigrade, the three gases hydrogen, iodine and hydrogen iodide exist together in equilibrium. The equation for the reaction ni hapo. What effect will an increase in pressure have on the position of equilibrium? Kama unavyoona huku na huku volumes zinafanana, so increase in pressure does not affect such kind of reaction. Increase in pressure has no effect on the position of chemical equilibrium because the relation does not accompany with change in the volume of the reagent. The reaction here have the same number of reagents inside of reactant and product, so increase in pressure will not affect the position of chemical equilibrium. And let's see example 4. The reaction nitrogen oxide then nitrogen monoxide is reversible, and from left to right endothermic, manake forward reaction. From left to right is endothermic. All reagent being gaseous, if system is in equilibrium, which at temperature which allow quiet rapid reaction. System is at equilibrium at temperature which allow quiet rapid reaction. What, if any, will be on the effect of the equilibrium? First, doubling the total pressure. Doubling the total pressure will have no effect on the equilibrium system. Why? Because there is no difference in volume between reactant and product. Doubling the pressure of nitrogen. Doubling the pressure of nitrogen will double the concentration of nitrogen. So the position of chemical equilibrium will shift forward. And lowering temperature slightly. If we lower temperature slightly, what will happen? Because from left to right is endothermic, lowering the temperature will reduce the rate of forward reaction. And then explain briefly why this reaction, when used industrially, was not catalyzed. What alternative was available? The reaction was not catalyzed because the reaction is endothermic. So it simply requires high temperature so as to favor the high production of nitrogen monoxide. No need of catalyst. But for the case of our process there, we needed the catalyst because the reaction was favored under low temperature. Now example 5, here we have this reaction, and then we have this I don't remember well, but is chromium. So I don't remember well the name, lakini tuna iron hapo, tuna water, tuna iron hapo, tuna hydrogen. Now this is orange by color and this is yellow by color. Now what would you expect to see? Because colors they are seen, orange na yellow unaweza kuziona kwa macho. Utaona nini? Unategemea kuona nini kama ukaongeza dilute sodium hydroxide is added to the equilibrium, au ukaongeza dilute hydrochloric acid, au anhydrous calcium chloride? Now this question is very conceptual. Yani hili swali ni kama conceptual questions za physics. Hili swali sio kucalculate. You don't calculate, just think. For example, if you add dilute sodium hydroxide ikidissociate in water itatengeneza nini? Hydroxide pamoja na sodium. Now hydroxide, they have ability to react with the hydrogen ions, and the decrease in hydrogen ions will favor the forward reaction. Then you will see deep yellow color or the yellowing of the solution. If you add dilute hydrochloric acid in the solution, dilute hydrochloric acid will increase the concentration of hydrogen ions. Increasing the concentration of hydrogen ions will favor backward reaction, and then the deep orange color will be seen. Addition of anhydrous calcium chloride. Anhydrous means it is dry or it has no water. So anhydrous calcium chloride will absorb water, and absorption of water will decrease the concentration of reactant. Decreasing the concentration of reactant will favor the backward reaction, and deep orange color will be seen. So yellow coloration, addition of sodium hydroxide removes hydrogen. Orange coloration, addition of HCl. HCl does not remove sodium hydroxide because here these were added different. So addition of HCl increases hydrogen ions, thus shifting the position of equilibrium to the left. And orange coloration of urea pare anhydrous calcium chloride absorb water, thus shifting the chemical equilibrium to the left. So in this video, let's end up here, and in the next video we will start discussing about the facts about the worked examples on the equilibrium constant. So share the video and subscribe the channel for more updates about chemical equilibrium, biology, physics, advanced math, and BAM. So thank you everybody. Subscribe the channel and share the video to your fellows. Thank you.